At 9:59 p.m. on September 30th, 2025, a magnitude 6.9 earthquake ripped through northern Cebu, killing 79 people and injuring over 1,200 more. Buildings crumbled, roads split open, entire communities were destroyed in seconds. But that wasn't the worst of it. The quake exposed something far more terrifying. A fault line that had been hiding beneath the island for more than 400 years. Scientists are stunned. The Bogo Bay Fault extends at least 1.5 kilometers on land, but earthquake patterns suggest the total length could reach 20 to 60 kilometers, mostly underwater, and nobody knew it existed. What else is lurking beneath our feet, and why did it take a catastrophe to find it? The U.S. Geological Survey recorded the main shock at magnitude 6.9, striking at a depth of just 5 kilometers. That shallow depth amplified ground shaking across a 200-kilometer radius. The Philippine Institute of Volcanology and Seismology initially classified it as originating from the Philippine fault zone, but something didn't match the expected pattern. Within hours, seismologists noticed anomalies. The aftershock distribution didn't align with known fault systems. By October 3rd, field teams from PHIVOLCS and the University of the Philippines documented a previously unmapped fault trace running northeast to southwest across Bogo Bay. Ground displacement measurements showed horizontal movement, classic right lateral strike-slip faulting, the same type that produces California's infamous San Andreas earthquakes. The official death toll reached 79, with 1,271 injured, according to the National Disaster Risk Reduction and Management Council as of October 30th, 2025. More than 159,000 structures sustained damage, including 7,701 completely destroyed homes. The coastal municipality of Bogo City bore the brunt of the destruction. Entire barangays were flattened. 4-story buildings pancaked. A public market collapsed during evening hours, trapping dozens beneath the rubble. Over 250,000 people live directly above or within 10 kilometers of the newly identified fault zone. Municipal engineer Roberto Tan spent weeks marking buildings with colored tags. Red means do not enter. Yellow means enter only to retrieve essentials. Green means inspected and safe. The red list keeps growing. The Bogo Bay Fault had been accumulating stress for more than 400 years. Historical records from Spanish colonial archives mention no significant earthquakes in northern Cebu between 1590 and 2025. Geologists at the University of the Philippines explain that this long silence is typical of strike-slip faults in the Philippines. They build pressure slowly, then release it catastrophically. The Philippine Fault Zone, which runs the length of the archipelago, has dozens of segments. Some are well mapped and monitored. Others remain hidden beneath dense vegetation, urban development, or underwater. The Bogo Bay Fault falls into this hidden category, a primarily submarine segment that only revealed itself when stress finally exceeded rock strength. Dr. Teresito Bacalco, director of PHIVOLCS, explained the discovery process. We knew the Philippine fault system was complex, but we didn't have evidence of this specific branch. The aftershock pattern gave us the first clues. Then ground surveys confirmed surface rupture. What makes this discovery particularly alarming is its location. The fault runs directly beneath one of Cebu's major cities and extends into heavily populated coastal areas. Unlike remote mountain faults, this one threatens critical infrastructure, ports, and hundreds of thousands of residents. Just over a month after the earthquake, Typhoon Calmady, known locally as Tino, slammed into northern Cebu on November 4th. Pagasa reported sustained winds of 155 kilometers per hour, with rainfall exceeding 300 millimeters in 24 hours. The timing could not have been worse. Buildings already weakened by the earthquake faced hurricane-force winds and torrential rain. Structures red-tagged as unsafe began collapsing without warning. Cracks in foundations allowed floodwater to undermine support columns. In Bogo City, at least 6 buildings that survived the quake collapsed during the typhoon. Then came Super Typhoon Fenghuang, locally known as Uwan, on November 9th. The Joint Typhoon Warning Center measured sustained winds at 185 kilometers per hour. The storm's diameter reached an extraordinary 1,800 kilometers at its peak, making it one of the largest tropical cyclones on record. The storm dropped massive rainfall across northern Philippines, though Cebu itself was spared the worst of Fenghuang's direct impact. According to the International Red Cross and Red Crescent Societies, the compound disasters have affected over 750,000 people across Central and Eastern Visayas. The back-to-back nature of these events has devastated communities with no time to recover between blows. Since the earthquake, sinkholes have emerged as an additional threat across northern Cebu. The Mines and Geosciences Bureau documented 198 sinkholes in the region before the earthquake. Following the September 30th quake, 14 additional sinkhole collapses occurred, bringing the total to 212 documented sinkholes as of October 2025. Geologists from the Mines and Geosciences Bureau explain the connection. The earthquake fractured limestone bedrock that underlies at least 60% of Cebu Island. These fractures allow water ground to flow into cavities, dissolving rock and creating voids. When surface soil collapses into these voids, sinkholes appear. MGB-7 geologist Faye Lorena Letta explained the mechanism. Limestone has inherent solubility. It dissolves easily with rainwater that reacts with carbon dioxide to form carbonic acid. This weak acid seeps through the soil and slowly dissolves limestone, creating underground voids that eventually collapse during earthquakes. In Barangay Nylon, Bogo City, sinkholes appeared near the fish port, and the sea level noticeably dropped following the earthquake. Councillor Naji Mandawe reported that about 15 sinkholes appeared in the sea itself. VIVOX Director Balcocol confirmed this observation, noting coastal uplift of about 1 meter in Barangay Nylon, while coastal subsidence occurred in Hagnaya, San Remigio.
Local governments have red-tagged properties in sinkhole-prone areas. The Mines and Geosciences Bureau warned that additional collapses remained likely, especially with continued aftershocks and heavy rainfall. One sinkhole was even discovered beneath a temporary evacuation tent city, forcing relocation of displaced families. As of October 19th, VIVOX recorded more than 12,700 aftershocks since the September 30th main shock. The largest reached magnitude 5.8 on October 13th, causing additional building collapses and sending terrified residents fleeing into the streets. 46 aftershocks have been strong enough to feel distinctly. Director Bakokol explained that this aftershock sequence could continue for months. Each fault behaves independently, he stated. We're still seeing patterns that suggest the system is adjusting. While another magnitude 6+ event on this specific fault is unlikely for centuries, significant aftershocks in a magnitude 5 range remain possible. The psychological toll is devastating. Sleep deprivation is epidemic. Children regress, bedwetting, nightmares, separation anxiety become common. Adults experience panic attacks at the slightest vibration. Buildings weakened by the main shock face compounding damage with each strong aftershock. Structural engineers need days to assess each structure, but the work never ends. Every magnitude 5 or larger event requires reinspection of all yellow-tagged buildings. Cracks propagate, foundations shift. The safe list shrinks with every significant shake. The economic paralysis is severe. Businesses remain closed weeks after the disaster, not because of direct damage, but because owners and employees are too afraid to work inside buildings. Schools operate outdoors when weather permits. Government offices function from tents. The initial mapping revealed surface rupture extending about 1.5 kilometers on land, documented through drone surveys by VIVOX in early October. However, earthquake scientists suggest that the actual fault length is much greater. Dr. Judith Hubbard, an earthquake scientist at Cornell University, explained that a magnitude 6.9 earthquake typically requires a fault roughly 20 to 60 kilometers. Since only 1.5 kilometers of surface rupture has been mapped on land, this suggests the remaining fault extends underwater in the Camote Sea northeast of Bogo City and possibly into Tanyan Strait southwest of San Remigio. Dr. Mario Aurelio, professor at the UP National Institute of Geological Sciences, analyzed the aftershock distribution pattern. He noted that aftershocks extend in a northeasterly trend from the offshore epicenter to the southern shores of San Remigio, passing through Barangay Nailad and Bogo City. Based on this pattern and empirical relationships between magnitude and fault length, he estimated a total fault length of approximately 50 kilometers, with about 15 kilometers on land and 35 kilometers offshore. The fault's right lateral strike-slip mechanism means that the ground on one side moves horizontally to the right relative to the other side during an earthquake. This type of movement is particularly destructive to buildings and infrastructure that cross the fault line. PHIVOLCS continues detailed mapping using satellite-based synthetic aperture radar analysis and ground-based surveys to determine the fault's complete extent. The agency has installed additional seismometers throughout northern Cebu to improve monitoring of future seismic activity. At Bogo City's covered court, 79 families, 392 individuals, lived in temporary shelter for weeks following the earthquake. Thousands more stayed with relatives or in other evacuation centers scattered across northern Cebu. As of October 30th, the Department of Social Welfare and Development reported that 753,993 people across Central and Eastern Visayas were affected by the earthquake. Elena Santos, 54, described her situation weeks after the quake. Her home of 30 years remained standing, but was tagged red by engineers. They say it could collapse in the next big aftershock, she explained. All our belongings are inside. Photo albums, my late husband's things, my grandchildren's baby clothes. But we can't go in, not even for 5 minutes. The psychological toll extends far beyond the displaced. Sleep deprivation is widespread. Children regress, bedwetting, nightmares, separation anxiety become common. Adults experience panic attacks at the slightest vibration. Roberto Tan, the municipal engineer responsible for building assessments, carries the weight of impossible decisions. Every red tag I put up destroys someone's life investment, he says. They argue with me, they cry, they threaten, but I'm trying to keep them alive. The next magnitude 5 aftershock could bring down any of these damaged structures. His job never ends. Every significant aftershock requires new inspections. Some structures that passed initial inspections developed cracks during subsequent shaking. Progressive failure remains a constant threat. The discovery of the Bogo Bay Fault forces a fundamental reassessment of seismic hazards across the Philippines. PHIVOLCS is now reviewing its entire fault database. If a major active fault can hide beneath one of the country's most developed islands, other undiscovered faults almost certainly exist elsewhere. Dr. Bakokol acknowledged the implications. This discovery challenges our assumption that we've mapped all major active faults in populated areas. We need to intensify geological surveys, particularly in urban regions where development may have obscured fault traces. The Bogo Bay Fault is classified as a right lateral strike-slip fault, similar to California's San Andreas Fault. This type of movement is particularly destructive to buildings and infrastructure that cross the fault line. Seismic hazard maps for Cebu are being completely redrawn. Building codes may need to be strengthened in areas now identified as high risk. Insurance companies are already revising premium structures. Property values have collapsed in the fault zone. Internationally, the discovery has attracted attention from earthquake scientists studying hidden faults in other densely populated regions. Japan, Indonesia, and parts of the United States all have complex fault systems where undiscovered segments may lurk beneath cities.
A dangerous myth circulates that because the main earthquake has passed, it's safe to return to damaged buildings. This misconception has proven deadly. The truth: aftershocks can approach the magnitude of the main shock and are far more dangerous to already weakened structures. Since September 30th, northern Cebu has experienced a magnitude 5.8 aftershock and 45 other felt events. Each brings new collapses. Fire Chief Roberto Tan has witnessed the consequences. We've pulled bodies from buildings that people were told not to enter. Every single time, they went back for belongings. Every single time, an aftershock hit while they were inside. Your photos are not worth your life. Another misconception: that aftershocks decrease steadily. While generally true, exceptions occur. The October 13th magnitude 5.8 event happened nearly 2 weeks after the main shock and was stronger than any previous aftershock. PHIVOLCS emphasizes residents should watch for these warning signs: increasing frequency of felt aftershocks, new cracks appearing in walls or foundations, buildings tilting or settling unevenly, or any red or yellow tags posted by engineers. Official guidance is clear: do not enter red-tagged buildings under any circumstances. Enter yellow-tagged structures only briefly to retrieve essentials, and only when no aftershocks have occurred in the previous 2 hours. Always have an escape route planned. Scientists at the Philippine Atmospheric, Geophysical, and Astronomical Services Administration warn that the combination of seismic activity and climate-driven flooding creates unprecedented compound disaster scenarios. The National Oceanic and Atmospheric Administration reports that Pacific sea surface temperatures continue running above normal, fueling more intense typhoons. When earthquake-fractured ground meets extreme rainfall, the results can be catastrophic. Saturated soils lose cohesion, slopes fail, rivers change course. Infrastructure designed for either earthquakes or floods, but not both simultaneously, may fail completely. The Cebu provincial government is now developing compound disaster response plans, but the challenges are immense. How do you evacuate people during a typhoon when buildings are unsafe from earthquakes? How do you stage relief supplies when roads collapse from both seismic shaking and flooding? Dr. Aurelia warns that the window for preparation is closing. Climate models project more intense rainfall events. Earthquake cycles continue regardless of climate. We must assume these compound disasters will become more frequent and plan accordingly. The economic modeling is sobering. A repeat of the September earthquake during peak typhoon season could displace over 500,000 people and cause economic losses exceeding 100 billion pesos. Critical infrastructure, ports, airports, power plants, all lie within potential impact zones. Today, more than 250,000 people across northern Cebu live directly above or near the newly discovered Bogo Bay Fault, a tectonic fracture that remained hidden for over 4 centuries before announcing itself with devastating force. The combination of seismic activity, sinkhole hazards, and climate-driven flooding created compound disaster scenarios that challenge traditional emergency response. How we rebuild, where we permit development, and how seriously we take geological hazards will determine not just recovery from this disaster, but resilience against future events. The Cebu provincial government is already moving to rezone high-risk areas. Volks warns that while the Bogo Bay Fault itself is unlikely to produce another major earthquake for centuries, the broader seismic landscape remains active and incompletely understood. Scientists have pulled back the veil on one hidden fault. How many more remain concealed beneath cities, farms, and homes across the archipelago? The Philippine Institute of Volcanology and Seismology is now prioritizing surveys of other heavily populated islands. But with over 7,000 islands and limited resources, complete mapping will take decades. Preparedness is not paranoia. It is survival. Hidden faults will move again. Whether we're ready is our choice.